Okay, we're going to look at elementary programming, and we're going to explore programming structures. Um, this module is meant to last a little more than 2 weeks, as we want to explore the concepts in Chapter 2 a little deeply here. We looked at how to start and compile and run a Java program. And what we want to do now is we want to make programs that can solve problems. So we're going to write programs that solve calculations. We're going to get input from the user so our programs can react to information coming externally. And we'll use identifiers that will name certain parts of our programs: variables, constants, methods, and classes. Variables is where we'll store data, and we'll use different assignment expressions to access the data. We will have constants that will have permanent values, and we'll look at the names we'll give to classes, methods, variables. What we'll then do is look at the types of numbers a computer can do. And one of the things we want to be aware of is because computers have bits that turn into numbers, they don't have an infinite amount of numbers in them. And even though they can calculate over a large range of numbers, this causes some small problems that we might see in additions and subtractions with decimal numbers that don't work the same as if we were doing the math by hand. And also division is different depending on if we are using an integer or a double. And so we'll look at the operators of addition, subtraction, multiplication, division, and remainder division. We'll take some powers with the math.pow library, and we'll write things in scientific notation. I'm not going to force using JShell to quickly test Java code, but because if you're using the Eclipse IDE, we get very quick test code out of the Eclipse. We'll look at evaluating anything we do numerically. We'll interact with the clock on the computer, and we'll look at how we can count by augmentation, which is both the post-decrement and the pre-decrement, and post-decrement and pre-decrement also. We will look at changing the type of a variable. If we have a variable that's an integer and we need to change it to a decimal, we'll look at how we can do that so that our calculations work properly. And then there are some example programs that look at particular calculations, loan repayments, and how to convert different amounts of money. And then we'll look at common programming mistakes that can happen when we try to set up these structures. There are common things that are bad setups, and we'll want to avoid them. So that's what we're going to do over the course of these next 2 weeks. One of the things I will always stress is I will give some example programs in the videos, and also use the example programs in the book. Type them in, have them run, and see what they do. The best way to learn programming is to type in programs and run them. And learning to read the programs are something that we need to do. So the book starts with introducing a program called Compute Area that computes the area of a circle. Now I want to come over to Eclipse and set this up. And I'm going to start a new project for all of Chapter 2 in Eclipse, and then we're going to add things inside of Eclipse. So I want to switch over to my Eclipse setup here. And in Eclipse, let me make my editor screen a little bit bigger. On the right-hand side in the Package Explorer, I want to right-click, and I'm going to go to New and make a new Java project. And I'm going to keep all of my Chapter 2 programs here. And so this pulls up a new window here. This window is not showing on my video screen here. So I right clicked, chose new project. Let me show you the window that popped up here, because it will go away shortly. Let's do a window capture, and there is the pop-up. And so what I want to do with this window is I'm creating a project for chapter 2. So I'm naming the project chapter 2, and notice Eclipse is giving me a warning. Hey, project name should begin with a lowercase letter. So I'm going to make chapter 2 lowercase. I'm going to use the default JRE that I have. I think most of you will have a JRE 18. I haven't updated my JRE in here to 18 yet. And I'm going to keep my project folder as the root. This will help me find things more easily. And this is a good setup for a new project. So I'll finish this. And what we want to notice here is, let me switch back. So I'm going to see the window went away. So I'll switch back. It drops down here, and on the right hand side I now have a chapter 2. I can hit the arrow next to it and I can see the Java libraries in chapter 2. And what I want to do is I want to right click on that and create a new class. So projects are places that we can store our class programs, and in chapter 2 I'm going to store all of the new classes that I do for chapter 2. So I'm going to come over in new class. And again, let me get the pop-up window that came up here. Here's the pop-up window when I create a new Java class. Let me make this a little bit larger. I strongly recommend watching these videos in full screen so you can read some of the characters on them. I've magnifying certain window boxes. I don't always have a preference for within my Windows settings. So the source folder is chapter 2, and it's going to have a default package called chapter 2, and these will be fine. I want to give this a name, and this is going to be circle area. This should start with an uppercase, and if I put multiple words together, I want everything lowercase except the first letter of new words. This makes this human readable. These modifiers are perfectly fine for right now, but what I want to do is I want to do public static void. I want it to create the basis for my class. So we'll hit finish, and that window is going to go away, and I'm dropped now down into this area here. And so notice that Java created from line 1, it has referencing package chapter 02. We'll learn more about packages at the end of this course. It has created my class name with circle area, and it has created the main method. And so what we're going to want to do here is we're going to want to use some variables to generate a circle, generate the area of a circle. So what I'm going to try to do is I'm going to try to take the mathematical formula for a circle. Now, one of the things we should always do when coding is we should leave good comments. Trying to on another window here. So in the class, in between package and class, we'll use the /**. So I typed in /**, and it set up a block. Anything from this opening / to the ending / is going to be a comment. And comments are not read by the Java compiler. They are to be human readable. And so what we want to do is leave a trail. When I work in industry, I would come back to my code sometimes after years and have to update things, this header information was a good place for me to know when I touch the code and to leave comments on changing. So right now, I'm going to say this is program circle area, and it calculates the area of a circle given the radius. And then because we're in a class situation here, we'll go, this is for CIS 150, WEB, and Professor Thompson. That will help me. We can look at it as like the top of a homework. And this is something that we should try to start including on all of our programs. Then created by Jeff Thompson and created on, and we'll put today's date 09/12/2024. Now, if this was code I would come back to later and I did changes to it, I would put revision 01 and the date and so on as a way of keeping track of any changes I made. And this is something all of your programs should have. It is a good habit to leave comments, so when you have to come back to your code or someone else has to maintain your code, they have a description of what's going on. Again, I have been blessed or cursed to work in situations where I had to edit my own code a couple years later, and I found that the code that I had commented well was easier to work with. Now, in all programs, we can have some basic structures that we tend to use. And if I want to make a one-line comment, I use the 2 forward slashes. Generally, I'll start with initializing data, variables, and data. Then I will input data. I will process my data and display the results. And then if there's any cleanup variables, to exit. These are sections almost all code will have. And so I put comments in place for this so that as I'm writing, I can think about what I need to do. In the program that I want to do to calculate the area of a circle, the area is the radius squared times pi. So I'm going to need a space in memory for the radius and a space in memory for the area. So I'm going to type in double area, and I'll say initialize variable for area calculation, and double radius. And since these are comments for myself, I think I'll abbreviate. First computer I had only had 2K of memory in it, and I had a very bad habit of not leaving comments. Now, one of the things we can do often, and especially in an environment like Eclipse, is as we're writing programs, we can check for errors. Now, right now, Eclipse over here is giving me 2 warnings. If I highlight the warning, it says the value of the local area is not used. So this will still run. I'm setting aside memory for area and radius, but because I'm not using it, Eclipse is just warning me I might be wasting memory. But you can run often, so I'll come up here and run, and Eclipse is going to ask me if I want to run. I hit OK, and it opens and exits without doing anything. But I don't have any syntax errors. I'm a big fan of run often. Make a small change, see what it does. Now, input data, in this case, we're going to say the radius is equal to 20.0. And so we'll set a value for the radius. Now this isn't really technically an input in the code. I am taking the memory I set aside for radius and I'm inserting into it the value of 20. Now I need to process the data that I have. And so I'm going to take the memory location for area and I'm going to put in that the radius times. And we use shift 8 for the multiplication symbol. The radius, that gives me r squared, times 3.14. What value of pi do I want to use here? 3.14159. We'll make pi. We'll estimate pi out. What do I want to use? Is 3.14 a good value for pi? Whoops. 3.141, yeah, 159. It will be good enough. So what I have done now is I have set aside memory for area. I've set aside memory for the radius. I've put something into the memory for radius, which is a singular value. I've used that singular value to do a calculation and put the result into area. So now I'm going to print this out to the screen. So system.out.println, and I'm going to print within my double quotes the area of a circle with a radius make this a little wider here and I'm gonna put a plus sign here and create a new line. The plus sign is telling the system.out.print that I'll print this string and then I'm going to add to the string, not mathematically add, but put a string, whatever is within the variable area. Of radius. The area of a circle with a radius of, and I'm going to ask what the radius is. And then I'm going to say what the answer is. And I'm going to end my line. So this statement here says the area of a circle of radius, and it's going to fill in what the radius is, and then it's going to fill in what the area is. And at this point, there's no cleanup I need to do. The program will exit when it comes down to here. So I've set up a basic program and I'm reserving some things in memory. I'm putting values into the memory and I'm doing a calculation on that. I'm then using the memory to display to the screen. And hopefully if I didn't make any major mistakes, this will work. So I'm going to run it. And notice my output that comes down below. It says the area of a circle with a radius of 20 is 1,256.636. And so it works. Now I could come back here and say, well, what about if I only had a radius of 1.2? And so I come back in and I change the variable and I run it again. And notice it's able to update what's in memory and do the calculations. This is not an extremely useful program. If I sent it out to a client, the client would only be able to get this one calculation. And we somehow want to make this idea of inputting data a little more flexible. But let's look at some of the structures that we've created here. So if we look at this program, and we get an idea of what we're going to call tracing a program. This is a good habit to have, that when you have a program that you learn to read it and kind of keep track of what the memory is doing. About 60 to 80% of coding is working on other people's programs. I have had many a time where I have gone into a client and they had running software that needed to be modified for new conditions. And so for those new conditions, I would go in, read the code, and see what needed to be done. So why leaving good comments is not just good for you, it's good for your clients, and it's good for the people that might need to use the code before. So if I read this down, this line double radius says it allocates memory for radius, but there's nothing in it yet. Then in the line double area, allocates memory for area, but there's nothing in it. Radius equal 20. What happens is that this equality sign is not equal like mathematics. It's an operation that has a direction to it. It says put the value of 20 into the radius. So this reads kind of right to left. It says take a value and put it into the memory. And so the memory will now contain 20. That means when we come a little bit further down here, and area equals radius times radius, this right-hand side accesses the memory for radius and does this calculation. It then puts the answer to the calculation into the memory for area. And so area gets this into memory. Then we come down to the system.out.print line, and this string gets printed. The plus sign says, all right, you're going to put another string into your output, and we're going to use the string that represents the number that comes out of the memory for area. Plus sign says put another string in, we'll put in the word is, and then the plus sign here says put in whatever's within area. And we get the value we saw on the screen in this little box here. So this is an idea of a basic program. All right, I'm going to cut these videos short. This is a full class lecture within my day class that I'm doing here, but I'm going to break it into little portions so you can go back and forth, try typing in the program and seeing if you can get it run. We're going to modify the program in the next little bit of the lecture to get input from the user.